AI is still considering the basic stage, because how it start evolving and it has no boundary yet. So, and lots of potential. Anyone, I think Ernest or K can agree with me or not. We know yesterday I was reading a white paper, and we are also trying to create a white paper on those same topic, that we are right now doing the face recognition system, right? And we have an idea that is absolute secure way, but AI, uh, with AI, you can there are way you can bridge this face recognitions system as well. So AI so far still late. Company is trying to implement on their infrastructure. Uh, um, um, uh, what is called for their productivity, but we are not far away that people we are going to use AI to bridge the security, right? Sachin, what is your thought about those? Because uh,
Uh,
bec-
so it's not just about the face detection, sir. The things are very, very diverse now. Uh, AI recently, we all know that Microsoft just laid off 7,000 employees just because
yes,
they are implementing AI, right? So in the near future, it might be happen that most of the jobs are going to be secured by the AI. But in the core, definitely we require some professionals, those who can understand or who can work entirely on the frameworks or who going to be do the entire research part there. So the face detection, object detection, right? Everything seems to be just near future thing, although uh, it is present in the real time not right now. But yes, definitely in the near future we are getting more for these applications.
but I would like to tell one thing. It's my observation. While the cloud came or DevOps came in back 4, 5, 6 years or maybe 10 years before, that
Mhm.
time we saw mass layoff, right? And we
Yes,
thought that
sir.
this automation will replace the many people's job. But at the end of the day, we found that it evolved and it create its own job requirement for DevOps and automations, right?
Mhm.
So
Mhm.
maybe right now AI is replacing many human hands, but it is also creating its own job role. So in my thought is it is evolving, and it is shedding its old leaves based on their skill set, and they are trying to hire a new leaves based on the new technology and new skill set.
Mhm. Mhm. Yes, sir. Yeah,
So
correct.
if someone is saying that no, AI is going to work standalone and only way for the company, not at all true.
No,
Whenever you
no.
are seeing
Right,
uh,
right.
whenever we are seeing the layoff, that means those are outdated skills people, or
Mhm.
those
Mhm.
companies trying to uh, you know m- um, uh, mm, migrate from old school to new school.
Near school. Mhm. Correct.
So as and software domain is always evolving. It's not like a any other job. Software and last couple of years is evolving very fast. Every days, every month, we are finding new and a newer technology and more secure technology, more scalable technologies. So as a software field people, everyone, even it's a student to
Mhm.
director CEO level, everyone need
Mhm.
to be on their toes to making sure that they are leveraging these things, and uh, and they are getting all those new skills under their sleeves.
Correct.
Guys, before we move forward, if you have any question or any discussion, feel free to ask. We can s- address those questions, and we'll take few 5 6 minutes question answer session. It will be a more or less 2 hours session for Mr. Sachin. You can have if you have any question regarding those course module, you can ask the question. Otherwise, we'll take another 5 minutes question answer sessions, QA sessions in between. Like so, Ashutosh asked one question: difference between agentic AI and Gen AI.
Okay. Genetic AI and Gen AI. See, there is not, you can say, a kind of very vast difference between the agenetic AI and the Gen AI. Gen AI is basically generating something using AI, right? While in agenetic, we are also doing the same kind of thing, but with a different kind of framework, transformers we require, right? We require, you can say, kind of some advanced networks, right? Advanced neural network through which you are going to create, like LangChain is there, Hugging Face is there, right? So you are going to use that things to create some advanced AI things. That is what basically agenetic. Although if you go into the core of it, right, you will not find that much of difference there. Anyone else? Any other question or doubt?
Guys, feel free to ask any question related to AI, our training, our free training, job related question, how to secure the job. Uh, we can share those. This is like a most interactive session you will find in on the internet, where many domain expert like Mr. Sachin, Mr. Devashish, where we have like a and few students like Ernest K, where you can communicate about those holistically about the IT field. Okay, Mr. Sachin, I think we can start and with answering then this question, then we can start for move forward for our today's session.
Sure, sir. One question is there. What is agent AI? Agent AI or agenetic AI? Who asked this question? Uh, Dainet. Agent AI. Are you talking about the agents in AI or what? Agents. Okay. See, agents are simply the uh, you can understand like this in a layman term. If I say agents are simply the workers that you are going to implement in your neural network. Okay. Understand through an example, very simple example. Um, okay, have you ever played some sort of game like, let's say, very famous game, Minesweep? Have you played that? On Windows, it come by default. Have you ever played Minesweep? Yeah. So in Minesweep, what you have to do? You have to figure out all the mines, right? So see what you are doing there. You are going to figure out a way so that you can reach to a reward. You are reach to a final destination, right? By avoiding all the mines there. So here the player is the agent. Okay. So agent in AI is simply the component who is going to take the actions. So there are some states, then we have reward function, then we have the next reward state, right? That is what agent in AI. I hope, Danit, you are clear. Okay. Okay. Now let's move on to the topic for today, that is called your CNN. And how many of you have gone through the presentation that is available on the website? Anyone try to go through? Good. Says I did. Good. Anyone else? Okay. Ashutosh is saying this is my first session. Ashutosh, there is a PPT available on the Kalki website. Have you tried to explore that? My first session. There's a presentation available. If it's not, so let's quickly. I need to find it out. Okay, no worries, no worries. So let me quickly just show it to you so that you can get a gist of what we are going to discuss today. Okay, just give me a second. Let me share and there's the PPT. Is the presentation. Presentation is not coming. Why? Okay. Have you guys getting my screen? Right. So here you can see that today we are going to discuss about the neural network, and a specific kind of neural network we are going to discuss, that is called the convolutional neural network. Okay. Although neural network is very old, you can say technology that we generally use to work on advanced technologies, right? Detection, identifying, and classifications. Now coming to the convolution, so what basically convolution is? So on a simple way, on a simple definition, or you can say simple understanding of convolution is when you are combining two different entities to generate a third one. That is the simplest understanding of convolution. Although if you go in the mathematical form, it is a quite different one, right? But as of now, just understand that what is convolution. Whenever you are, you can say you are merging two different entities in terms of neural network, we call them as formulas, right? Or networks. So whenever you merge two different formulas to create a third one, it is called as a convolution, right? So there is a simple some information about it. So this is a evolution of CNN. So initially it started in 1980s. Then first we have LANet, then XLNet, and then the modern CNNs, right? So in the modern CNN, we have a lot of like ResNet is there, Inception is there, VGG is there, right? Uh, some framework is also available, like you can say YOLO framework is also there, correct? So that you can also use for the CNN part. Uh, we have some limitations. That is why we came up with the CNN part. Okay, so a standard neural network become inefficient, high dimensional data. Now, can anyone tell me that what is high dimension? How can you define dimension in data set? Anyone worked previously with complex data structures or complex data set? Anyone? What is dimension in a data set? Yes or no? Simple. You guys aware of that or not? Okay. See, so dimensions are nothing. Dimensions in terms of your data set, dimensions are simply called as you can see the features you have. Okay. What is dimension? Dimension is simply the features we have in our data set. Okay, so when we have a lot of dimensions, lot of features in our data set, so the classical machine learning algorithms are not that much able to work. For example, if I say there is a machine learning algorithm that is called PCA. Anyone know about that? What's PCA?
Principal component analysis.
Correct. Principal component analysis. And what is that? Principal component analysis?
It is used for dimensionality reduction, reducing the number of features, input
Correct.
variables.
Correct. Absolutely right. Good. Very good. Right. So PCA is very classical, you can say, algorithm that we generally use for working on high dimensionality data. It fit into a smaller set. No, it will not fit into smaller set. What it do, what PCA do, PCA convert all your entire data set into two component that we called as PC1 or PC2, that is principal component 1 and principal component 2. Now, what is the, you can say, the condition of the principal component is that there should be no loss of information. That is the condition, right? But PCA, you can only, you can see, you can only use it for very, you can say, restricted amount of data. Means if you have a numerical data, only then you can use it. What if you have a data which is in the form of images, right? Because at the end, what you need to do, either you are going to do the classification from the image or you are doing the detection from the image. Correct. So first of all, what we need to understand here, we need to understand that how the image or how we are going to work on the image, how the image generates. Getting my point? Right. Now, can anyone tell me what is the component in an image? Anyone?
Pixels.
Good. Very good. Pixels. Right. Pixel. And what are pixels? Pixel image coordinates. Okay. Picture elements. Okay. Anyone else? Right. Right. So pixels are simply the coordinate. Okay. Let me share the my whiteboard now. Okay. I need to write a lot of things now. Fine. So let's begin with this. Just a second. Oh. So let's begin. So what is CNN? As I said, CNN is basically a neural network that we are going to use to work with the images, right? Now coming to the first thing, which is very important, that is to understand about the image. Now, so when I say image, so image means that we are talking about some numbers. And numbers in terms of image are the pixels, right? Okay. Numbers are the pixels in terms of image. We know that every image is primarily composed of three components. What are that? We have height, we have width, and we have one more thing which is very crucial, that is channel. Okay. Height, width, we know. This is height, this is width. Now, what is this channel is? Any idea, anyone, what the channel is?
I think colors, the colors of the image.
Colors. Exactly, colors, right? That is why whenever you have an image, there are two types of channel you will find. First is RGB channel, and another one is grayscale, right? These two, RGB and grayscale. Grayscale means monocolor images, that is black and white. While RGB is the colored images, that is we have three channel is three here. Anytime if you see that the you can say the input for any network is given, let's suppose for example an input is given like 32 by 32 by 3. So what that means, here the 32 is height, then this 32 is the width, and this 3 is this channel here, that is RGB. Everyone clear till this point? Range of color, correct. Range of color. Yes, no, guys, clear?
Yes, sir.
Anyone have any question, doubt? Okay, now see. First of all, let's understand the architecture of this CNN, right? So when we say CNN, it doesn't mean that there is a single entity or single layer which will do the entire work. No, there is a whole lot of components in CNN. Okay, so what basically happen in CNN? First of all, there is an input, and input in this term we generally have an image. Okay, this image goes to a layer, kind of layer, which we called as convolution, and there is one more layer available which is called pooling. Sorry, not pooling, it's pooling. Pooling layer, right? So there could be multiple pooling and convolution layer. So this image got from, or it goes from multiple convolution and pooling layer, right? And finally, it reaches to a another layer, which is called flatten layer, like this. After this flatten layer, we have hidden layer, that is the dense layer in which your entire object detection part happen. That is in which your entire classification part happen. Okay. So here we have like this multiple sort of neurons. These are the neurons we have, right? And finally, we can either do the classification. So these are output, and finally we have your output here, right? So every neuron is connected with each other. Like this. Okay. And finally, we have this output layer where you will get the this entire is your dense layer. This is your output layer. And finally, you will have your output, which might be a kind of different objects or might be an image, right? Now, one by one, we are going to discuss about all of them, right? Before that, anyone have any question or doubt in this part, you can go ahead with that. Guys,
Hello,
any
sir.
question or doubt? Sorry, go ahead.
Hello, sir. Can you hear me?
Yeah, go ahead, go ahead.
Can you? Okay. At this last part of output layer, the
Hmm.
two neurons there,
Hmm.
is it that the two of them are being um used as the output, or one of them is being selected to be the output, like the final result or end uh, goal for the whole processing? From the two, is it that the one with the highest weight of value is being picked to be the
No,
output finally, or
no,
what?
no. See, you are not, uh, you can say, providing any designation to any neuron. Okay. The simple thing is that on the basis of the, you can say, if you have attended the previous lecture, we have discussed about the activation function. Any idea about that?
Yes, sir. Yes,
Right,
I have.
right. So on the basis of that activation function, the output is generated, and we are going to configure the neurons. Okay, we are not defining any neuron for a particular thing, or for a particular input, or for a particular, you can say, image. We are not going to do that, right?
Okay.
Okay. Anyone else? Any other question or doubt? So neurons stores feature that are classified. No, never. Neuron will never store. Neuron never store. See, that is the primary difference between any neural network, specifically if I'm talk about artificial neural network or convolutional neural network, which separates the recurrent neural network. So what is recurrent? Recurrent has a specific feature that we call as memory, which stores your previous data, which stores your previous input, which makes it separate from the these two types of data, neural network. So neuron are not going to store anything there. Neurons only have the mathematical formulas. That's it. The summer is there, activation functions are there. And a neuron will take the input with some weights associated. On the basis of that, it will define that which feature is effective or high, having a high priority, and which one is having a low priority. Getting my point? Right. Anyone else? Do we use max pooling and average pooling? Okay. Coming, we will discuss about it later. Just give me a second, okay? Apart from that, anyone else? Any other question? Okay, so let's begin. See. One by one, let's understand what this convolution and pooling layer, right? So as I said that what is convolution? So in this convolution layer, we require one input layer, we require one hidden layer or dense layer, and finally we have the output layer, that is the entire CNN structure. Simple, right? Now one by one we will understand what is convolution layer. So convolution definitions say that when you have two function and you merge them to generate a third one, that is what convolution is, right? Let's suppose for example I am saying that by merging two functions, let's suppose I am saying that fx is a function which is ax plus b, right? And there is one more function that is yx. And yx is saying that a square x plus b plus c, right? So what I can do, I can merge them to create or to get the output for c. Yes or no? I can find the value of c from these two functions. Yes? Using fx or yx, I can find or not? Getting this example or not? I go with more simple one.
Yes, we got it. You can go ahead.
Okay, right. So that is if I merge them, if I merge these two functions, right, and generate a third one, let's suppose I am saying zx. So this zx will be called as convoluted function. Convoluted function, right? Everyone clear? Now, next. Just try this. Now see. So after the convoluted function, we will next see there is a very crucial thing that we need to understand that are called kernel, right? Now, what are kernel? Let's say, okay, let's understand like this. When we work on image, right? Is it necessary every time that we get the relevant data? When I convert the image, can we have the presentation slide? It is on the Kalkey website. You can find it there. Okay. So I'm talking about the image. Is it every time necessary that when I convert the image to pixels, I get the relevant information, I get the relevant data from the image? Is it possible every time? Yes or no? No. Correct. Right. So generally what we have, the data which is not relevant, that type of data is called as noise, right? What we call is as noise. Okay. Now, in CNN, this kernel, which we generally in a common language called as filter, is basically a matrix. Kernel slash filter, right? Which is simply a matrix. And generally the size of this matrix 3 by 3 or 5 by 5. So 3 by 3 means like this, 3 rows, 3 columns, like this. This we are going to apply during the convolutional process. Means when the functions are merging, at that time we are implementing this kernel. Getting my point? Yes, no? Guys, are you getting this or not? Kernel part?
Yes, I will do.
Okay. Now the question is that what is the purpose of having this kernel, right? When we already have the convolution layer, the pooling layer, right? Now what is the purpose of it? Why we are implementing kernel? Now understand. Here comes the concept of kernel. So when in the process of convolution, what happened? We apply this on the input image. So this kernel going to be applied on input image. Basically, this applied process is called the slide. Okay, we are going to basically slide this matrix on the entire input image, that is on the entire pixels of the input image. Now the output that we got after applying this is simply what we called it as feature map. That is how to extract the features that we do using this kernel after applying it on the input image. Getting my point? Yes or no? Till now we haven't discussed about feature. We only discussed about the image and all. Correct? But from the image to generate the output, you require feature. And how that feature we are going to extract using this kernel. Clear? Simple understanding. Yes or no? Okay. RGB we have discussed, right? The channels we have discussed. RGB channel, three types of channel we have: grayscale, monoscale, right? Fine. Now coming to the next part. Just over. Okay. Fine. Now we need to discuss one more thing, which is called padding and stride. This one, padding and stride, right? What is padding and what is stride? We have to understand it. See, sometime what happened when you got image, right? When you got input, your images varied in your size. I'm talking about the actual size of the image. Okay, might be you have a cluster of images and every image has a different size, correct? So before applying the neural network, before applying any CNN on that, what we have to do, we have to scale down, or we have to you can say make sure that every image has a same scale, so that we can apply the neural network efficiently on that. So there comes two type of method, which is called as padding and stride, right? What we call as padding and stride. Getting my point? Yes or no? Guys, anyone have any question, doubt right now? What happens when the input image is smaller or larger than the filter in a CNN? Okay. See, the same thing I was discussing, that what happened when the input image is smaller or larger. What actually happened, if I can't show you how the movement happened, right? But a layman term, if I give you, let's suppose this is your image, right? And the image size is 32 cross 32 cross 3. This is your image. And you are applying a kernel of 3 cross 3. So what will happen? This 3 cross 3, that is for every 9 cell, you have a matrix like this, okay, which captures the, you can say, the data or the pixels values in this 9 cells. Then again, this metric move to the next. Now this is your next. So here again you have 3 by 3 kernel, okay, and similarly this kernel will move to every portion of your image. That is how the kernel identify the image, identify the data, identify the features from the image. That is why we have kernel size of 3 by 3 or 5 by 5, because most of the time if you have a very large image, 5 by 5 means that will be 25 cells will capture most of the features from your image. I hope you are getting my point. Bang up. Right. Okay. So that is how, see, that is how the kernel move through the you can say every pixel of the input. That is what we call as padding and stride. Okay, there comes the process of this padding and stride. So what padding say? I was discussing about this padding. What is padding? Padding means how many pixels are adding. Now, question is that why we are adding it, right? The answer is, what we need to do, we need to you can say we need to figure out the relevant, you can say relevant features, right? So basically what happened here, if I give you, let's suppose this is one image, right? You applied one kernel here, and if I say padding is equals to 1, let's say, so what will happen? It will add 1 pixel every time your kernel moves, so that it can identify the edge detections. What we call it as edge detection. Okay, from your entire image. Getting my point? Yes or no? Okay, right. And what is stride? What is stride? Stride says that every time when the, it's not, oh, sorry, right, stride says that every time when the kernel moves through the pixels or the image, right, how many pixels it shift, that we called as stride. Okay, means, let's suppose for example, if I say padding equals to 1 and stride is also equals to 1, so what it will do, it will move 1 pixel at a time. Okay, resultant of it, why we are providing the stride? Resultant is we need to generate the output. output generation, right? Now, I'm not saying that just after applying the padding and stride, the output generate. No, we are going to discuss about the pooling as well now. Getting my point? Yes or no? Okay. Now see. So what happened when you apply this padding and stride? If I apply the padding on stride, the spatial, you can say spatial geometry of an image get increased. Okay. So for that reason, what we have the next process that is called pooling. Pooling. Now what happened in this pooling? Understand. So basically what pooling is basically we perform to reduce the spatial dimensionality of the image, right? Not spatial, it's spatial, S-P-A-T-I-L, spatial. That is your geometrical dimensionality of an image, right? So what happened here? Understand. Let me just delete it up. Okay. So see, here we have pooling, which we use for the spatial dimensionality or reducing the spatial geometry of the image. Now what happened? Understand. Let's suppose this is an image. And here I have by 3, and let's make it 4 by 4. Three and 4, right? 3, 2, plus 3 and 4, like this. Let's suppose this is my image, right? And after you can say after applying the convolution and all that things, what we got, what I got some values for it, right? Let's suppose 1, 2, 4, 0, 9, 3, 6, 5, 2, 1, 7, 8, 5, 6, 9, might be 4 as well, right? So this is your image, which is your convolution output. Convolution output, right? Now what we do, I need to reduce this image such that I can get the maximum feature from this. So how can I do that? So for this purpose, we have a method that we call pooling, right? So what we do, we apply pooling layer. So there are two types of pooling layer, which is called max pooling and average pooling. Okay. Yes, no?
Yes, sir.
Now, so what is max pool? Max pool means that if I applied a pooling layer here, let's suppose I'm applying the pooling layer of 2 by 2. Pooling layer of 2 by 2. So 2 by 2 means total of 4 cell or 4 pixel, right? So this is your first 2 by 2 pixel. So what max pool say? Extract the max value. So what is the max value? 9. So how the resultant uh, convolution output will look like? Now it will generate like this. Okay. So from this max pool, extract the highest value, which is 9. Then through this second grid, right? Because 4 by 4, that is 2 by 2, will make the 4. So this will be your next grid, this one. From this, it will extract the maximum value, which is 6. Same thing happen here. Again, we get 6. And same thing happen here. We get 9. So you can say the entire image is now reduced to 2 by 2 instead of 4 by 4. Previously, it will be 4 by 4, and now it is only about 2 by 2. Getting my point? Yes, no?
Yes, sir.
Okay. Now, coming to the average pooling. What is average pooling? Right? So average pool means the same thing happened, but now we are going to calculate the average here. Getting my point? What we will do? We will calculate the average here. So what is the average of this first grade? 12, 14, 15. 15 by 4. What will be that?
3.6.
Something. Yeah, 3 point something we are getting, right? But fraction, it will not take. So how the okay, okay, right? So let's suppose I'm getting 3.6. So let's suppose it is 4. Then the next will be 15 by 4. So 15 by 4 again we are getting 4, right? And 9, 14, 14, that is 4. Again it's getting 4 around, correct? Then 12, 19, and 19 plus 9, that is 28. 28 divided by 4, that is 7, right? So this is how your average pooling works. This is the resultant of average pooling. This is the resultant of your max pool. Getting my point? Anyone have any question, doubt right now? Yeah. Okay, so let's just have a look at the presentation. Just a second. Stop share. Share. Okay. Okay. So we discussed that.
Hello, Sachin.
Yes, sir.
Yeah, there is a question for you.
Just a second. Okay, in which instance do we use max pooling? Okay, in which instance do we use max pooling or average pooling? Okay, see. So there is not such a you can say rule provided that where you can implement the max pool or where you can implement the average pool, right? That depends on the complexity of your data. If you are working on images which are having a specific high dimensionality, then it's suggested that go for the max pool, right? But if you have images which is having low dimensionality, but you need to extract the you can say lot of features from the images, then go for average pool. Getting my point? Okay. Anyone else? Any other question, doubt? Benga, you have raised your hand. May I know? Okay. Right. So, okay. No worries. No worries. Let me. Yeah, we were talking about this, right? So we have discussed CNN, why we require it. CNN overview we have discussed. Input layer is there, hidden layer is there, fully connected. Fully connected layer is nothing, just the layers or the dense layer we have, like just like in the neural network. Okay. And finally, we have the output layer. Convolutional layer, so building block is there. Learnable filter like kernel, we have discussed about that, right? That slide across input to detect specific features. Now we have activation map. So activation map are simply the activation functions that we are going to use, or the activation, you can say a specific map which generates after applying the feature mapping and the activation uh, functions there. Finally, we have special preservations, that is maintain relationship between the neighboring pixel for context, right? Spatial preservation means that how we are working on the dimensionality, how we are working on the complexity of the image. Either we are applying the pooling, padding, stride, right? These are all comes under the spatial preservations. Now, finally, we have some activation functions. Okay. Now discussed about the activation function. Okay, how many of you attended the first session when we were discussed about neural network? Okay. So any idea what is neural, what is an activation function? Anyone? Non-linearity into a neural network. Okay. Non-linearity in the network. Correct. Non-linearity. Anyone else? Anyone in? Any other idea? What could be an activation function? Okay. See, so the basic definition of activation function say that it is a function which triggers the neuron to get activate. This is the layman definition of an activation function, right? Now we are having some specific activation functions when we are working with a CNN part. Okay. Yes or no? No. So let's discuss a little bit about the activation functions. Okay, I hope the screen is visible. Yes, no? Right. Now let's discuss about activation function. So what is activation function? Which will trigger your neuron, right? So here we have the very famous activation function that is called the ReLU. 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 It stands for rectified linear unit. Rectified linear unit. Just give me a second, guys. Let's quickly grab some water. Just a second. Right. Okay. So now we will discuss about the rectified linear unit. What is rectified linear unit? Why we call it as ReLU, right? So it simply says, if I write down the function for the ReLU is So it simply says max of 0 z, this one, right? Now what this ReLU means, ReLU says that if you have a positive output, okay, that is the probabilities, positive probability, I will show it through the max. If you have negative probability, I will represent it by 0. Simple. This is what rectified linear unit is. All the negative will become 0 and all the positive, it will extract the maximum for that. Getting my point or not?
Can you explain again?
Sure. See, so let's suppose, for example, I'm saying that for a specific image, right? When I passed an image through the entire CNN network, I got some probabilities. And let's say I got probabilities, few I got in negative and few I got positive. Okay. So what this ReLU will do, all the negative probability will convert to 0. And all the positive probability, what it will do, it will extract the max value from there, which is the maximum probability from that, all the positive probability, right? Now it's clear. Right. But now this is an issue as well, right? What if there are some negative probabilities which are also, you can say, relevant for the network or for the output, right? So how we are going to identify those, how we are going to work on that probabilities? Okay. So now there is one more function appear, or one more activation function, which is called leaky ReLU. Leaky ReLU, right? So leaky ReLU means what it will do. In ReLU, we have discussed that all the negatives will become 0. Correct? What leaky ReLU will do? That is when you get some negative values, right? That is when z is negative. So what leaky ReLU do? It allows a small non-zero gradient that is called alpha. Okay. What it will do? It will allow a small non-zero constant gradient, which is called alpha, which will not convert the negative values to 0. Getting my point? Yes, no? Okay. Now, can anyone tell me that what is gradient, first of all? How can you define gradient? Anyone from the math background or engineering background? Slope. Okay. And how you are going to calculate the slope, Keshav? How we calculate slope? By the input negative values. Okay. See. So gradient is simply the slope, right? And simply how to calculate the slope? So slope is calculated by del y by del x. Now, what does del y by del x mentions? Okay, what it gives us. Understand. Let's suppose, for example, I'm saying that there is a function like this. This is a function, right? And I need to calculate the minimum change of from it. Let's suppose I'm calculating. Let's suppose I'm calculating this part. This part. Okay. I'm calculating this region. So how I'm going to calculate it? So for this purpose, what I need to do, I need to calculate the gradient of it, which is simply the del y by del x. That is differentiating your y, that is differentiating your function with respect to x. That is what we call gradient. And it is one of the.
Sorry, can you please explain that in layman's terms?
Which part?
Gradients instead of using the dy dx looping.
Okay. See, so in the layman term, okay, let's suppose like this. You understood linear graph? This is a linear graph, right?
Yeah.
Okay. Now, if I say that there are 2 points on this line, one is this x1 and this y1, right? So it will be somewhere like this. This is our x1, y1. And I need to check slight difference here. This one. So let's suppose I'm saying this will be your y2 and this will be your x2. That is what I'm doing. I'm checking the displacement, the minute displacement. Okay. So the coordinate for this will be x2 comma y2, and the coordinate for this one be x1 comma y1. Yes or no?
Yeah.
Right. So how I'm going to calculate it? It is simply the change between the coordinates. So how can you find the change between the coordinate? That is y2 minus y1 plus x2 minus x1. Yes or no?
Okay.
Right.
And what is that?
Which one?
Y2 minus y1 plus x. Is that the gradient?
Yes, in layman term, it is slope that I have represented here through this dy by del y by del x. Now it's clear.
Yes, yes. So when you say vanishing gradient in this context, what does it mean?
Okay, fine.
I know you mentioned it the last class.
Vanishing gradient. Vanishing gradient is a so what we do generally, we try to figure out we call it as minima, right? That is why I have represented this graph, this function. You see, this is alpha, which is called the gradient, right? So what we try to find the max optimal value of it, which is called the learning rate. Okay. So basically what we do, this is your learning rate and we want to figure out this point. This is called your minima, global minima. Okay. Vanishing gradient is a problem actually, right? Vanishing gradient we have discussed. I don't think so that we have discussed vanishing gradient. Have we discussed?
No, you just mentioned it. We didn't discuss it.
Okay, okay. We haven't discussed. Okay. Anyone else? Any other question? Points of interest for me to it is a rate of change of the concerned values. Okay, x2 minus x1, y2 minus y1. Oh, sorry, I put it the wrong formula. The formula is wrong. Escape from my mind. Guys, the formula I have put it wrong. My mistake. This will be x2 minus x1 on y2 minus y1. This one. Okay. Now, so when we introduce this gradient, right? Now there is situation appear. Understand? What situation is? Let's suppose, for example, if I provided this alpha in such a way that it tries to learn every feature from your data, what will happen? Will it make my neural network fast or slower?
Slow.
Slow. Everyone agreeing on that? Yes or no? That if I provide a gradient value, if I'm providing a gradient value in such a way that it let every, you can say every neuron to learn every feature from the data, will it make my network slow or fast? Means the convergence time of the network will become slow or will become low or high. What will happen in that case? Slow, definitely slow, right? So when this thing happen, takes longer time. Correct, correct, right? So when this thing happen, when you provide a learning rate which is quite smaller, it makes your network very slow. This problem is simply called as the vanishing gradient. Okay. Yes, no? Now understand. Noted. Okay, good. Now understand why it happened. We understood that it makes the network slow, but the question is why it happened. If you remember, in the neural network, when we have our first session, uh, we discussed a term that is called back propagation. Back propagation. How many of you remember this? There are two type of network. One is feed forward and one is back propagation. Right? Understand what is back propagation? Back propagation is basically when you are trying to figure out the optimal weight. Okay, in case your feed forward neural network is getting into the condition of overfitting, then we calculate when we apply the back propagation now. So what happened in the back propagation? We apply chain rule, and if you know what chain rule is, anyone, what is chain rule? Chain rule. Chain rule is basically we apply in mathematics. So what we do, we multiply the derivatives. Okay, what we do, multiplying partial derivatives. Okay, getting my point? Multiplying partial derivatives by layer. Just give me a second, guys. Why this tab is lagging? Just give me a second. I'm just sharing it again. It's lag. Open it again. For the same. I hope the screen is visible. Yes, no? Can you guys confirm that whiteboard is appear?
Yes, sir, it's visible.
Okay. Now let's check if it is. Yeah, it is now. Okay, so we were discussing about the this chain rule, right? So what happened in this when you apply the chain rule? So your derivative gets multiplied by layer, right? And when we say multiplied by net layer means what happened? Your derivative, that is your del y by del x that we are going to calculate for the function, is going to be multiplied by very small numbers, right? Going to be multiplied by a small number, which eventually generates a, you can say, exponential result, right? This exponential result, when although if it is already multiplied by small number, so definitely the exponential result will be small, which makes your neural network slow. That is the reason, that is why it is called that that vanishing gradient is the situation in which your network gets slow. I hope it's clear now. Vanishing gradient and all. Yes, no?
Yes, yes. Thank you.
Right. Any other question, doubt, anyone? No one? Right. Similarly, just like we have this ReLU, in the same way, you can apply other activation function. One very famous one, which is called your okay, which is called sigmoid. We have already discussed about it. Sigmoid function. What is sigmoid, guys? What is the specific thing about sigmoid? Specialty about sigmoid?
It's
Anyone?
for it's for linear function, for linear setup for the application function.
Sorry, come again.
I said it works in a linear setup, in a linear arrangement for the activation function.
Okay, it will work on a linear. See, understand. So what is sigmoid? Sigmoid basically says that it will convert your probabilities into binary output, that is 0 and 1. Can you run a small model for us to see these settings? Definitely, we are going to do that. Don't worry. I will show you how to work on it. Let's just complete with the basic and then we will move. Okay. Like sigmoid, we have 10H. ELU is also there, right? Now let's do one thing. Okay, first of all, let's check whether we have left with anything or not. So I'll just stop share here for a moment. I hope everyone got the PPT. The presentation is there or not? I'll share the presentation quickly. Once we just discuss it, then we will move on. See, so here now we discuss about the activation function, right? So ReLU is there, sigmoid is there, 10H is there, leaky ReLU we have discussed, right? So these are the famous activation functions are there. You can use. Then the pooling layer is there. So downsampling, reducing the spatial dimension of the feature map, that is we have discussed. Max pool, average pool, and translation invariance. So what it will do, it makes basically what translation invariance says. It simply manages all the features in a scale, that is reducing all the complex features on a single scale, so that you can easily implement your the neural network, and the neural network easily identify the component or the features from that and generate the optimal output. Okay. Then we have fully connected layer. So fully connected layer, we have complete connectivity, that is every neuron connected to every layer or every previous neuron to the every previous layer. Then spatial to vector transformations, convert spatial data to class probability vector. Vector are basically the you can say the entity or the mathematical entity in which you have both, that is magnitude and direction. That is what we call as a vector. Okay. In terms of mathematics, you will find some sort of terms like tensor. When you start working with libraries, or when you start working with the data, there is a specific library for that we call as a tensor flow. So what is tensor? Tensors are nothing. Tensors are simply the combinations of the matrix, and matrix are generated from the vector. So that is how you can understand vector, right? Then feature hierarchy integration is there. Then finally we classify the output, right? So this is the basic understanding. Then dropout layer. Okay. Dropout layer. Understand. I think okay. We haven't discussed, or can quickly confirm it. Have we discussed the dropout layer previously or not? So that I can just give a quick reference to this.
Sir.
Have we discussed dropout layer?
Yes, sir.
No. Okay. See. So what is dropout layer? Now assume like this, that after the in a dense layer, I have these neurons, right? These are the number of neurons I have. Now tell me one thing. When the information first appear on the first input layer, that is the first hidden layer, I'm talking about this. The same input or the same information will goes to the second layer or not? Will the second layer needs to process the same information or reduced? There will be some reduction in the information. Anyone?
Please, would you repeat the question?
Question is, let's suppose I am saying that in the first hidden layer, in the first layer, I am saying, let's suppose there are 1,000 inputs, right? And when these 1,000 output goes into the second layer need to work on the same number of inputs or not? Yes, no?
No, sir, can you hear me?
Yeah, go ahead.
I said I think it will be reduced.
Correct. Definitely it will be reduced, right? Now tell me one thing. If it is reduced, so that means I definitely need to restrict some neurons here to work, right? So that is what dropout is. Dropout simply says, dropout means restricting the neurons to work in layer. That's it. If I provide, let's say if I provide dropout value, dropout is equals to, let's suppose I am saying 0.1, right? So that means what I'm doing, 1% of the entire neurons will be deactivated. Okay. Right. That is what dropout is. Clear, everyone? Yes or no? Okay. Now, so after the dropout layer, random deactivation, right? So we are simply deactivating the neurons here. Prevent overfitting. Obviously, when you will deactivate some neuron, okay, it will benefit you or your neural network to converge in less time, which will generally overcome the situation of overfitting. Then dropout layer, dropout rate is typically 0.02 to 0.5, that is 22 to 50%. Redundant learning, force network to develop robust feature detector, improve generalization to the unseen data, right? So this is what dropout layer is all about. Then padding and stride we have discussed. Okay. Optimizers we have already discussed in the neural network part. So these are basically some you can say some functions that will give you the optimal learning rate. Okay, and it will optimize your neural network in layman term. So there are some like Adam optimizer is there, GSD is there, gradient descent is there. Gradient we have just discussed what is gradient, right? So this is how you can understood the optimizers in CNN. Framework, so there are multiple framework like TensorFlow. I just said that when you start working on complex data or images, you need to work with TensorFlow. Apart from that, there are PyTorch, Keras is there. Okay, so in combination, we are going to use this TensorFlow, Keras, and PyTorch. Correct? Then these are the applications where you can implement CNN. Like in computer vision, you can go for object detection, semantic segmentations, right? Real-time application, there are some applications is given like autonomous vehicles, security surveillance, manufacturing, social media, healthcare, and all. Future directions and challenges, efficient architecture, explainable AI, few short of learning, and ethical considerations. So few short of learning means you have a lot of framework where you don't need to provide that much of coding part, that much of line of code, or you don't need to define you can say components of the network, right? Your framework can identify those automatically. Okay. Training effective model with limited label data. Then sorry. Okay, so these are the things that we need to discuss in your CNN part. Getting my point? I hope everyone. Now, if anyone have any question or doubt, you can go ahead. Yes or no? Anyone, guys? Any question or doubt? If not, let's try to move a bit to the implementation part. Okay. So let me I haven't shared anything. Create a new file. All right. So one by one, we are going to start by importing the necessary files. So first of all, I'm importing the NumPy, right, which is necessary for to work on the arrays. Then I'm importing one more, that is import matplotlib dot not pyplot. I'm going to use image as mpimg image, right? Then one more I'm going to import by matplot. Okay, data set. Oh, fine. Okay, now matplotlib dot pyplot as plt, and okay, first of all execute this. Done. Now I need here one more library which is called as TensorFlow, right? So let's first of all try to import it. Let's see whether it is available or not. So import tensor of TensorFlow as TL, right? Execute it. Let's check whether it is available or not.
Sorry. So you mentioned that TensorFlow was a framework for CNN. What exactly does it do?
Okay, TensorFlow, see, TensorFlow, as I said, what is Tensor? Tensor is a combination of matrix, right? Matrix which generates from vector. Okay, and till now we have discussed that what is an image? Image is simply the combination of pixels where you will get grid, where you will get the matrix formations, right? To you can say to work on those matrix, we have this specific library, we have this specific framework which is called TensorFlow. Getting my point?
Yeah.
Right. Instructions, instructions. The operation table does approve with the appropriate compiler flags. Okay. Now I need the keras as well. Start data sets. Nice. Okay, done. So I'm using one very famous data set here, which is called the MNIST. It is basically a digit, some blurred digits are there. So you can use this data set to detect the digits here, handwritten digits there. Okay, Now, next. So first of all, let's create the X train and Y train. So it will be X train, comma, Y train. Okay. Now here I'm going to create the X test and Y test. Is equals to class dot data sets dot MNIST dot load underscore data. Okay. Cannot unpack non-retrievable function object. Now what is happening with this? MNIST is there. What is not loading it? String like from test for test. No. Happen here. Not unpack non-retrievable function object. Set. Once I attribute load data set. The, what happened with the function? MNIST we have used here. Right. It's not working. The data function is right. And why it's not working? String. Okay. Let's try to download this data set, guys. It's not working from the Keras, right? So we need to download it from the external source. How much time? Oh, we have only 3 minutes left. Okay, let's do one thing. I'll just
No issues, Sachin.
I'll
We can
download this
continue.
data.
We can continue the next session. That is
Sure, sir.
fine.
Sure.
That is fine. That's fine.
Anyone have any question or doubt before I just conclude the session?
Sir, can you quickly explain how does that padding and stride works?
Okay, see, so padding and stride, basically what it do when your kernel moves on your image, right? For example, I am saying that there is an image of 32 by 32 and your kernel size is 3 by 3, that is 9. So that 9 cell or 9 cell matrix moves with or the entire image. Okay, so in that case we need to provide a value to the padding, that is either one padding for one or stride. So if I'm saying stride 1, so what it will do, it will only shift only one cell at a time. One cell means first it will read the 9. Then the first row will exclude, it will move to the next one. That is 1. If I give it 2, so the first 2 column will exclude and it will move to the next one. That is what padding and stride is.
Okay. And what is kernel exactly? It is the program that we are trying to, read the images.
Come again, what is?
What is the kernel exactly?
Kernel is the filter. Either you say it kernel or you say filter. Both are same thing.
Okay. And it reads the images.
Yes. That entire kernel moves on the entire image or the pixels.
Okay. And it stores the information somewhere.
No, it will not store it will only extract the information. It is not going to store anything.
Okay. Thank you.
Anyone else? Any other question or doubt? Right. Okay. So this is what we have to discuss in today's session. In the next session, we are going to discuss another type of neural network that is called the RNN. That is your recurrent neural network. Is that fine? Clear, everyone? Yes or no?
Yes, sir.
Right. So we will meet in the next session. Till then, have a good day, guys. Goodbye. And thank you for joining the session, guys.
Thank you, sir.